All right, good morning, guys. I just wanted to come on here and make a video about kind of reinforcing how to do these problems on our TI Inspire. I think Desmos has made life a lot easier, especially in this climate where we're not in person and I can't really like troubleshoot and help you guys individually because I know the calculator is a little bit overwhelming because there's so many clicks, there's different spots to find things. So I'm going to show you how to do that again on a video because I do think it is valued because you can't use Desmos on the SAT, but you are going to be able to take in your TI Inspire for those type of tests. So let's go over this projectile motion problem here, all right? And I'm going to show you on my calculator. And this is a problem that we ended class with last week, and we'll even look at it more so in our next class. But we're given this function, and in this problem, we're told that the marshmallow is fired out of this marshmallow shooter at 26 feet per second, right out from your bedroom window, which is 30 feet above the ground. So I'm given my initial height, 30 feet. I'm given my initial velocity. Write the function that models this particular problem. So I'm going to go open up a graph here. And in the calculator, you always put x. You can't put any other variable but x. You take your time when you do this because sensitive, you can easily make mistakes. All right, so negative 16x squared plus 26x plus 30. Let's just double check that. Initial velocity, initial height. We're good to go. We're going to hit enter. And look, a lot of times, guys, you might not see the graph as you want it on your initial screen. So when you hit menu, that's going to be where a lot of your tools are, right? Specifically, menu 4 and menu 6. Menu 4 gets you to your viewing window. All right, let's just say we want to zoom out. All right, we want to zoom out a little bit. We want to see the top of this, which I do now. But it also looks very condensed. To me, it's not easy to see. So I'd rather take another minute. And I'm going to hit menu 4. And this time I'm going to actually change my settings. And I'm going to condense my screen a little bit. Right now it's really spread out, but my graph is so narrow. We just kind of bring things in here. And let's make this a negative 10. And let's make this a positive 10. So literally, the width of our screen is going to go from negative 10 to positive 10. The height I wouldn't change just yet. Let's see how adjusting the width. All right, so see what that did for us. We now see things pretty clearly. At least, I don't know, I feel better about that. So again, window, zoom in and out, or change your settings to more specific values. All right, is all right there. At this point, I'm going to hit menu analyze graph. And I could be wanting to find a 0, a min, a max, an intersection point, a lot. So I'm going to find the maximum here because our parabola opens downward. So this point that I'm pointing at right now with this cursor, that's my vertex. It's my maximum. Except the TI Inspire, you have to do a little more to get that point to appear. It says lower bound, which means go left of this point. You don't have to worry about getting it so close. You can give yourself room. Go left of where it is and click. And then once you click, it's then going to say your upper bound, which means now drag to the right and click again. And now we have that vertex. All right? And with these problems, we know that we should be thinking of them as time and height. So when x equals 0.813 seconds, this marshmallow was 40.6 feet above the ground. That's how you interpret that. And going back to our question, that's pretty much the answers to B and C. What is the max height? When does it get to the max height? All right. At what time does the marshmallow hit the ground? Well, it hits the ground right here, and I'm trying to point to it. And ground level is when y equals 0. Okay? So in other words, I want to find the zero of this function. Now, this problem, I don't need to figure out this zero. I could if I wanted to, but let's just say we want to focus on this one right now. Again, it's going to ask me lower bound and upper bound. So go left of where that zero is and click. Then go to the right of it and click again. And it's behind this, but there it is. All right, 2.4 seconds, right? X is in seconds. So even though it's not needed, let me just do that again. Menu 6.1. I'll find this one, right? Click left, drag, and click right. And there's our other zero. Okay. Something else that you might be asked, as we'll see today in class, is if I want to figure out, well, what's the value of X when Y is, in this case, let's say 37. Well, the TI Nspire has the ability with this table, okay, where I could bring up a table and I could try to find 37. But the problem is that it's only for specific integers, like 1, 2, and 3, not decimals. So that might not be the best route. But let's say we go to our graph, and let's enter a line here that shows y equals 37. Well, where this line intersects my graph, that would be my answer, because that line's intersecting it at a height of 37. I just got to figure out what the x values are. So menu 6.4, intersection. Again, lower bound, upper bound just means drag left, drag right, and click. Drag left, drag right, click. So there you go. Now again, Desmos is a lot easier, a lot more like user-friendly. But if you understand lower bound and upper bound, just be aware that menu analyze graph or menu window zoom is going to get you to kind of the things that you need to answer these questions. All right, guys, so I hope that helps. As always, just continue to ask questions if you have them. I'll talk to you later.